Go to the ASU West bookstore, pay them $1 for a pink Scantron, or maroon Scantron if your masculinity is threatened by asking for something pink. Okay. So you need a pink Scantron. And also, if you don't want me to have to hand grade them, and trust me, you don't, because I make mistakes much more than the Scantron machine does. If the sucker gets all ragged and dog-eared, the machine won't read it. And then I'll hand grade. And then I'll give you 50% because I can't read my own writing. Yeah? So keep it clean. Keep it clean. 2 weeks. I will bring extras and I will publicly shame you for not bringing your own. Yeah, let's get started. We're going to work through this. This week, I want to consolidate. What's the exam? The exam is everything we've done, plus there's a squeensy teensy bit of magnetism. I will need that for our next section. What I'm going to do is I'm going to front load this with your knowledge is hopefully fresh about electricity and electronics. We're going to spend this week reviewing, connecting, telling you all the answers to the exam. Slightly modified, don't just memorize. And and then next week is a little bit of magnetism. There's a magnetism lab. If you're on campus for this lab, it's good, it's great. And then the week after is exam week. Questions about structure, procedures, administration? Yes? Is my schedule still messed up? Let me look. Let's find out. I would not be surprised if I still goof. Which goes to show that even the best of us, Harry, make mistakes.
Yeah. I think that's it. It says Wednesday on post one.
Wednesday the 11th. Yes, Wednesday the 11th. Oh, that's just in time for you to give your score to your beloved for the day of obligation. Okay, forced. There is one new puzzle piece. Fill in the blank. What? C, D, what? No. Right, I wanted to ask another thing. I said this out loud, and I should never say things out loud. Define V. Define I. And when I say define, I want the equation. Give me the equation that is always true about voltage. Don't write a sentence. Don't tell me units. Tell me the equation that defines voltage. It must always be true, not just sometimes. Hint, hint. Think about what is. You do it. And I need to be able to see your responses. Nope. Nope, 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 nopey, nope, nope, nopers. Okay, my friends, you are not ready. Write this down on the top of your page. Now go get a tattoo of it on your forehead. Backwards so you can read it when you look at your face in the mirror. V equals IR is a statement about one kind of electronic component. There are dozens of kinds of electronic components. We've only been talking about resistors and batteries so far. Riddle me this, how many ohms is a battery? What's printed on the side? Does it tell you ohms? No, it tells you volts. The point of a battery is to keep a constant voltage across it, yeah? That's how I sort of defined battery on the first day of batteries. So the resistance of a battery is not a thing. It's not a resistor. Only a resistor is a resistor. If you've got a resistor, V equals IR is a true statement, but not everything is a resistor. Is the resistor in the room with you right now? So V equals IR cannot possibly be the definition if R only happens sometimes. Only some things have an R. This is not universally true. This is universally true. The meaning of voltage is energy per coulomb of charge having that energy, or energy of possessed by a coulomb that could be there. When we talk about electrostatics, static electricity, and electricity and magnetism together, you will need absolutely to know that V equals IR does not even apply to static electricity. And there's still perfectly well-defined voltage, even in free space outside of circuits, where there is no I, where there is no R. If everything just stuck in place, there's still voltages. That's what you feel instantly when you scuff your feet. Is there a resistor hovering in midair? Is there a resistor in the room right now with you? If you scuff your feet on the floor and feel that feeling. If you go down the playground slide like we all do at 20, and feel the static electricity, is there a resistor there? No. There's still voltage. You're feeling the voltage. Voltage is energy per charge. What's I? Let's see if people define that correctly. No, 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 yes, no, yes, yes. Okay. The meaning of current as I defined it at the beginning. Did I talk about resistance on day 1 at all? Did I? Did I? I think I introduced it day 2 at the end. I don't know. Resistance is good. It's great. It's important. It helps you understand what voltage and current are. Thank you, Gina. But you don't need resistors to have current. R is for resistors. But current doesn't have to flow through a resistor. Current is charge per time. Q over T is what I was looking for. Reflect on this. V equals IR is not universal truth. It's not even true for a resistor. If you put enough current through a resistor, guess what its voltage becomes? Well, its resistance changes. And then the voltage across the current through it goes to 0. Anyway, my point is, and I do have one, voltage is energy per charge, current is charge per time, and V equals IR doesn't define anything but resistance. Oh, for dog's sake. Now, I want you to think about what a voltmeter, that is to say, a meter which measures voltage, really, it's a big surprise there, and an ammeter, which is the fancy name for a current meter. Think of it measures amps, it's an ammeter. Does a voltmeter want electricity to flow through it or not? Does a current meter want that current to be inside it or not? What makes sense? If you've got a circuit where the electricity is being measured, you want to measure the electricity. Do you want current to flow through a voltmeter or an ohm meter? Ready, set, go. You decide. Think about it. The choices for C and D are either must or must not. Don't write the whole sentence. Turn to your neighbor and discuss, by the way. Current is kind of like traffic. If you open up a side lane, are you measuring the traffic in some lane? If you open up a bypass, are you measuring the current cars in the original highway? If you want to measure the number of cars on a highway, where do you have to put your traffic camera? Do you have to put it on a bypass or no? Parallel is bypass. We're attaching in parallel, we're attaching as a bypass. If you want to measure how much traffic is changing from place to place, how much the density of traffic or something is changing from place to place, the irritation of drivers as they're driving along, does it make sense to have that electricity flowing through, or do you want to look at two places or one place along the road? Here's an analogy. I think if I want to measure a current flow, I'd better make sure that current flows through my current flow meter. If I want to measure current flow, that current had better darn well flow through the meter I'm trying to measure the current with. Ammeters are always in series, hint. Okay. Likewise, if I've got a voltmeter, if I have current flowing through the voltmeter, am I not disrupting the flow of traffic? Am I not changing the circuit that I applied to? The correct answers are must not and must, respectively. If you have a voltmeter hooked up to something and that voltmeter draws current, you're changing the circuit. Current is not flowing in the same way as it did before. Likewise, if you have an ammeter that is not hooked up in series, or an ammeter that has resistance, an ammeter that doesn't feel the current flowing through it, you're not measuring the amps that you're trying to measure. Look, here is a very simple dinky little circuit. Two resistors. Nevertheless, this is actually a component, a sub-circuit of a whole butt ton of actual real-world circuits. Suppose I've got a 24-volt battery, a 6-ohm resistor 1, a 4-ohm resistor 2. I'm going to ask you how to measure the voltage through across R2 and the current through R2. Where would you put the meters? You don't have to put this in Google, but on your paper, sketch this circuit and indicate where you'd put the A and where you put the V. The symbols, by the way, to measure amps, you use an A in a circle. To measure volts, you use a V in a circle. And the lines that are coming out of those are the wires that attach to the red and the black leads that attach to the circuit. So put an A and put a V around the circuit in the appropriate places so that you can measure how voltage changes from place to place and how much current flows through place to place. Then turn to your neighbor and criticize their drawing skills. Again, what I just said before, an ammeter must have low resistance. An ammeter must have the current flowing through it that you wish to measure. A voltmeter must oppose the current, must not let current flow through it so that it can measure the original pressure without disturbing the circuit. If you build a bypass, you're going to change things about the traffic flow. No current through a voltmeter. Yeah.
The voltmeter measures the potential difference between the two.
Yes. What happens if current flows along that path? Exactly.
That is why it is put in the parallel.
Yeah. Okay, so hopefully on your papers, you have drawn an ammeter in series with your resistors. Doesn't matter where, remember, anywhere in series, current is the same. You don't like that. Turn to each other, discuss why it has to be somewhere in series with the components. And then I want a question. No, I want two questions. Why must the ammeter go there? That's what you should ask each other. I got so distracted and I completely forgot. Yes, absolutely. Let me look at the poll again to see when we decided, and I will make an announcement. Okay.
Like the majority.
I will send out an announcement. Thank you for reminding me because I totally forgot. No, you're good. Okay, I want 2 questions. Give me 2 questions. Show me where you don't understand so that I can fix it. Please.
Like that's what you're measuring, that's what you're using a voltmeter in, or?
Well, we only know about 2 things so far. We know about batteries and resistors. If you want to use a voltmeter to measure the voltage across something, you're measuring the voltage across either a resistor or battery, yes. Why does the resistor, please?
Like join the voltmeter parallel to any of the points and not both the.
Wait, if I put a voltmeter like here,
Okay, but somewhere else and not above the,
like there,
not right there. Let's say on the third line.
here, yeah, really, yeah, or are you just saying yeah because you're tired? Okay, well, let's ask this. What do you all think? Tell me what the voltage at that point is between those 2 points. Again, you should remember, you should know, ammeters draw all the current that flows in the circuit. Ammeter is effectively a 0-ohm resistor. Ammeters do not restrict the flow of electricity that they're trying to measure. I mean, if you had a ruler which magically shrunk you, would you be measuring you? No, the meter shouldn't affect the quantity it's measuring. Okay, so what do you think? What would that voltmeter measure? If this ammeter is effectively a wire, how's that voltmeter hooked up to that battery? Google Form E. What is the reading on the voltmeter? I can't tell if you guys are shy, lost, or both. Let's find out. E, tell me E. I want E. I hope this is easy. An ammeter is effectively a short circuit. It doesn't block up resistance, doesn't block the circuit. What does that voltmeter measure? That's what I ask. What does the voltmeter pictured measure? Yes, Gina, ask me a question. Yes, Gina, yes. You have to tell me that. That is the question for you. Okay, here's the answer. How's the voltmeter connected to the battery? In parallel. What do you know about parallel voltages? They're the same. If it's 24-volt battery, how much voltage does the meter feel? 24 volts. The voltmeter here reads 24 volts. The same, exactly. Voltages in parallel are the same. This voltmeter is in parallel with that battery. Hey, is R2 parallel to battery? Yes or no? Google question F. Is R2 parallel to battery? Usual form. Question F. Oh, whatever. Google form F. Is R2 in parallel with battery? Well, that's much better than usual at this time. Good, 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 good. I take full credit. This class is getting it. Good. The answer is no. This is not in parallel to this. And my reasoning why is it's connected on the bottom, but it's not connected on the top. There's R1 in the way. Yeah. Question.
Like the overall structure, like that's no junction.
That's series.
Oh.
Series is if they're connected, no junction. Directly connected, I should say. Please.
Like, this is the setup.
Zero. The voltage here is the voltage there. There's no resistance along the wire.
There's no resistance. The voltage will be zero.
The voltage difference is zero. The voltage compared to ground is 24. But you're measuring the difference in height between two equal height people. I'm 6 feet, you're 6 feet. A meter held between our heads says zero. Okay, so thank you for asking that, by the way. So the correct answer here is no, R2 is not in parallel. Things are parallel if they touch directly on both ends. R2 touches directly the negative terminal of the battery, Yoda I am. R2 directly touches the negative terminal of the battery, but R2 does not run into the positive terminal of the battery because R1 is in the way. Yeah, you feel okay with that definition? They connect directly once and only they connect, that's series. They connect directly twice, parallel. Okay, so what? So let's not erase the things. What's the voltage here? Google question G. What's the voltage there? This is what I'll ask on the test. Something just like this. R2 is not parallel to the battery. Hint, 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 hint. What is this, G? Are we on G? G, right? G? Hint, we are not in parallel with the battery. Very not parallel. Sahyu, did you like the color trick? Coloring the wires? It's all up to you. Should I teach him? Worth it? Worth the time? Well, let me also ask. Hey, how many people are still nervous about series parallel rules? Give me a big show of hands. Okay, okay. Before I answer this, that's the question. That's what I asked you. But hold on. Before we go to this, if series and parallel are put you on the struggle bus, here is another way to do it. Get out some colored pencils, get out a highlighter, get out something with multiple colors. Get out a stylus that, whatever. We'll come back, we'll do this. This problem is not dead, just me. Here are the rules. Every wire gets a different color, that's it. Shade in every wire a different color. This is connected by wire to this. That wire connection gets green. This is a different wire connection, so it gets pink. This is a different wire set. That gets orange. Orange. Now let's talk about the pairs of colors. The true colors. That's why I love you. What pair of colors does the 9-volt get? I mean, just look at it. What are the pair of colors? What color is this? What color is this? So I would say that this is a green-orange pair. Green to orange. Can I just abbreviate it green, G and O? Everyone knows their colors? What is the color difference across R1? Purple green. What's the color pair across R2? Okay, pink and orange. This is orange, this isn't purple, right? Look, to my eye, this looks like green orange, green pink, or you could say purple, I don't care. For God's sake, I can't think. Pink to orange. And pink to orange again. VM stands for what? Voltmeter, that's right. Okay, here's how to find series and parallel. Yeah, question first. The 9-volt. That was a test and you passed. It's the bat. No. It's the battery, yeah. Thank you. Okay, here are the series parallel rules in colors. Things are in series if they share a color that's unique. So, is there more than one orange? Yeah. So things that have an orange are not in series with each other. The voltmeter is not in series with R2 because the battery is also orange. Yeah? Things are in series if they share a color that's unique. What's a color that appears only twice? Green. There's only two things that have green in them, battery and R1. Battery is in series with R1. Parallel rule. If things share colors. For instance, R2 and voltmeter are both pink-orange. Every color is a different, potentially, different voltage level. So the difference in voltage is the difference between pink and orange voltages. They are not in parallel with the battery because pink orange and green orange are not the same phrases, last I checked. R1 is not in parallel with R2 because green and pink and orange are not the same words. So things are in series if they share a unique pair of colors. Things are in parallel if they have the same pair. R1 and R2 are not in series. Are not in series because green, pink, orange, pink is shared. Pink is shared by voltmeter. And nothing else shares green. Yeah. They have to share a unique color. Pink appears 3 times. It's not unique. Now, as it happens, voltmeters draw basically zero current. Voltmeters have really big resistances. In practice, 100 million ohms is not atypical. So how much current goes down the voltmeter? 0. So you could replace this circuit with nothing there. As it happens, R1 is, yeah, basically in series with R2. All of the current that leaves R1 is going to flow through R2. So in this particular example, when the voltmeter has basically infinite resistance, nothing is flowing there, you could imagine that it is gone. I mean, if we're measuring the voltage across R2, the voltage shouldn't depend on the voltmeter. But I'm not going to ask you if, in this example, is voltmeter in parallel or it's R1 and R2 in series, because the practical answer and the theoretical answer are different, and I'm not going to give you something ambiguous. Yes?
We substitute the voltmeter with a third resistance.
Yes, let's talk about that. Yeah, what about it?
R2. What about R1 and R2?
You tell me. Do they have a unique color?
Actually, to be honest, like this color thing, so I'm not focusing on that.
Okay, so what color do R1 and R3 share? Look at the words. Uh-huh. Yes. R1 and R3 both have pink. Does anything else have pink? So is it unique? I said things are in series if they share a unique color. R2 also has pink. So this pair is not unique. So these are not in series. R1 is not in series with R3. The other way I described it, if you hate colors, if you're colorblind, things are in series if there's no choice for the current. There's no choice. Yes, there is. There's a choice for R1's current. That current can go through R2 or through R3. It splits. Now, what I was saying a second ago is for a voltmeter, if a voltmeter passes no current, effectively infinite resistance, does the current split? If there's 0 amps flowing through the voltmeter, is the current splitting? No. That's why I said effectively, if this is a voltmeter, then they are series. The currents are the same. But I'm not going to ask you that on a test. I will say with resistors where the answer is unambiguous. You won't have to apply common sense to it. Questions about this? Again, same pair of colors parallel, unique pair of colors, unique shared color, series. Another example? Sure. How about, here's a battery, here's a resistor, here's another resistor, here's another battery, here's another resistor. Yeah? One more resistor. No, another resistor. Hope you have a lot of colored pencils. Try this one. And for the sake of discussion with your classmates, call this R1, R2, R3, R4, R5, battery 1, battery 2. Now you can talk to each other. Okay, try the color game. Or if you hate colors, you could simply say to each other, what series, what's parallel with what? I don't want to spend all day on, no, this is really important. If you can't see series and parallel, you're screwed. So no, we can take all day on this if we have to. Can I start drawing colors with that you guys see? I can. Can I freeze this? Can I freeze this? Please let me freeze this. That does not freeze. That does not freeze. That does not freeze. Okay, I don't know how to do that. Okay, I'm going to draw some colors. Every wire gets a unique color. What's going to show up differently? Oh, actually, I can just draw. Okay, again, look for, do two components have the same pair? That's parallel. Do two components have a color that nothing else has? That's series. Great. What's a unique pair? What's a color that two components have but not a third? Brown? Bang, 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 all have brown. Green. There's only one green line. So if battery 1 and R1 have green and nothing else has green, does that mean that they share a unique color? Yes. So therefore, series. What about blue? Are the components touching blue sharing a unique color? No. Therefore, what can you say? No. You could say not series. To check parallel, we have to ask a different question. Things aren't either series or parallel. They're not opposites. You can have both. You can have neither. Okay, so if they share a non-unique pair of colors, if they share a non-unique color, that does not mean parallel. It means not series. How do we check parallel? What did I say about parallel? What did you just write down about parallel? They have the same pair of colors. Great. Give me a pair of colors. The two components have the same. Blue-brown. What component has blue-brown? Oh, hey, black is a series. R4, R5 are in series. That's correct. Okay, R3 and R what? R3 and R4, right? Blue-brown, blue-black. Did I say the same thing? No. So what can you conclude? 3 and 4 are not in parallel. Does that mean they're in series? No. The combination of 4, 5, what's the left side of the or one side of the combination of 4, 5? The outsides of 4, 5. If we found the equivalent resistance of 4, 5, that goes from, look at the outsides of 4, 5. What's 4, 5 connected to on one side? Blue. And so if I found a parallel series combination of R4 and R5, I could say that combination is in parallel with R3. Yeah. But R4 is not parallel with R3. You cannot use the, well, you can use the parallel addition formula, but you'll get it wrong. Is there anything else in parallel in the circuit? Wait, there's nothing in parallel in the circuit. Yeah. We cannot say, well, we can say it. You can say it all you want, but it's wrong. This pair of colors, black and blue, are not this pair of colors, brown and blue. Black is not equal to brown. Things are in parallel if their colors are the same. Yeah. Which two and which two? B2 and R2. What colors are B2? And a pair of colors. Okay, red and brown. What colors are on R2? Did you say the same thing twice? Then no. He said red and brown, and then he said red and blue. That's not parallel. He asked, are they in parallel? Oh, are they in series? What's the condition for series? Great. Is anything else red? Then they're in series. Yes. Sorry, I heard parallel. Do you see how this connects? If there's a unique color, that means they're connected, but there's no junction. If they have the same pair of colors, then there's a wire connecting their tops and a wire connecting their bottoms. See how that's the same thing? Just a little more colorful? Great. With that in hand, no, give you the simpler circuit. With that in hand, find for me the voltage across R2. Did you finish this? Are you completely stuck? That's what my 9-year-old says. 2-year-old. You're not stuck, you're not done. Okay, well, chop chop, quick like a bunny. The more you do, the more answers you get to see. You don't like the colors, do you? You don't like the colors? No. Totally optional. You don't like the colors either, do you? You don't like any of it? Well, ask more. I know you are capable of asking wonderful questions. Bring it up. Bring them out. Show me where you're struggling. G? Was this G? Therefore, you are. G, Keegan. Killed by coffee, that would be hilarious. For me. Well, no, for everybody but me. Hey, wait, hold on. Put a note with the colors. If A's in series with B and B's in series with C, A and C don't share a color, right? They're still in series. If I'm in series with you and you're in series with your sister, I'm in series with your sister, right? If two things are in a line and then two more things are in a line, they're all in a line. Even though there are then not a direct color in between. You can have chains of series. I will also remember, wait, who's Guck? Who's stuck? No, yeah, a couple, okay. Here is Tucker's patent pending method for solving resistor circuits. Find total resistance using the series parallel rules. Find total current leaving the battery by Ver. You know the total voltage, you know the total resistance, you can find the total current. Then keep dancing back between V equals IR. If I know the V and the I here, if I know the V and the R here, I can find its I. If I know the V and if I know the I and the R, I can find the V. So let's do this as an example. What's the total resistance? 10. R1 and R2 are in series. Remember what I said, the voltmeter is not really drawing any current. Any current that leaves R1 has to flow into R2, yeah? If the voltmeter is effectively infinity? Effectively, for the purpose of analyzing the circuit, if there's no current flow through the voltmeter, then you could just add R1 and R2. Here, it makes you nervous, I erase it. On a test, I won't ask something with an ambiguous answer. I will not ask you, is R1 in series with R2? Because the answer is, well, basically. And that's not a yes or a no. If you think that I've asked an ambiguous question, raise your hand and call me over. And I'll tell you, well, what I'll either tell you is I'll give you a hint or I'll tell everyone in the class, hold on, this question is being thrown out. If it's unfixable. R1 is in series with R2. 6 plus 4, 10. Okay? If they're 10 ohms and 24 volts, what's the current? 2.4, exactly. 2.4 what? 2.4 amps. Current is measured in amps. Good. 2.4 amps leaves the battery. Where's it go? I've been talking too long. Google question H. If 2.4 amps leave the battery, how many amps flow through R2? Again, Google question H is, if we have discovered 2.4 amps leave the battery, how many amps flow through R2? Zero volts is not the correct answer. Let me ask an alternate question. I see 5 cars enter the Broadway tunnel. Broadway tunnel? What's the tunnel underneath Central Phoenix? What's that called? The 7th Avenue tunnel? Is that what we call it? Whatever. 5 cars enter a tunnel. How many cars exit the tunnel? Do 6 cars exit? No. So if there's 2.4 amps leaving the battery, how many amps are there in R2? 2.4 amps. And it's the same charges, moreover. Yeah. Any series circuit. If there's a choice, if there's a junction, and that junction draws current, unlike having a voltmeter. If there's a junction, if there's a third resistor with non-infinite resistance, then there's a split, and they're no longer guaranteed to be the same. Okay. So, part 1, find R tote. Part 2, find I tote, 2.4 amps. Part 3, if I know the I in a component and the R of the component, I can find the V of the component. Ver. So what's V in R2? I've got 2.4 amps and 4 ohms. How many volts? 9.6 is correct. Hey, there's a trick, by the way. Ready? You want the trick? I don't like long calculations. Well, that's a lie, but no. You don't need to know about that. What's 9.6 divided by 24? Oh, isn't it 0.4? How did I do that? How did I do that? There's a trick. What did we just do to find the current in R2? We did V tote divided by R tote. And then what did we multiply that by? So the voltage in R2 is the same thing as the V total times, I'm just going to rewrite the fraction in a different order. A voltage divider, you can express in a single word, as a single sentence, the idea, the voltage at the output, the voltage across a resistor is proportional to that resistor's share of the total resistance. A resistor's share of the voltage is equal, a resistor's ratio to the total voltage is equal to the resistor's ratio to the total resistance, right? That's how I was able to discover so quickly 9.6 divided by 24 is equal to 4 divided by 10, or 0.4. I did that instantaneously without having to be calculatoring. MCAT people, here's a trick you might remember. By which I mean you should learn. Look for patterns. No, you guys don't like that at all. Write this down. Meditate upon this. The voltage divider circuit. 1 battery, 2 resistors in series. A resistor's share of the total voltage is equal to that resistor's share of the total resistance. A resistor's share of the total voltage is equal to that resistor's share of the total resistance. If this were 5 and this were 13, What fraction of the total voltage would this sucker have? This is 5, this is 13 ohms. 5/18. Correct. The total resistance would be 5 plus 13 is 18. His share of the voltage resistance is 5/18. What if this were 2 ohms and that were 5 ohms? 2/7, right? The fraction of the total resistance would be 2 plus 5 is 7. This guy is a 2 now, so 2/7. So it'd have 2/7 of 24 volts, or whatever you apply. What if this were 16,500 ohms and this were 16,500 ohms? What fraction would this have? 16,500 divided by 16,500 times 2. Let me write it on the board. If R1 and R2 are both 16,500, can you solve this math puzzle without a calculator? What's that number? 1/2! If I add two things together, it is twice as big as the individual thing, right? Okay, so if you have equal value resistors, they split the voltage evenly. Half and half the voltage, 12 and 12 in this case. Okay? Feel better about that? No? Some of you, yes, some of you, no. Let's talk about the current equivalent. Here's a test question. Merry Christmas. What fraction of the total current goes through I2? Goes through the 2 ohm resistor. What fraction of the total current goes through the 2 ohm resistor is the test question. Put this in what? I? Are we on I or H? I. I. What fraction of the total flows through the 2 ohm resistor? I was already at P by the time I hit this at 3. They needed more help. G 9.6, Mickey. Mickey. Hint, here's how to find the fraction of one that is the other. Find the one, find the other, divide them. If you find I1 and find I2, the fraction of the total is just I2 over I1. It's right there. If I earn $5 and my family brings in $15 an hour, day, whatever, then I have 1/3 of the total. My fraction of the total is 1/3, 5/15. Find the 5, find the 15. You can do this. You have everything you need. Or you should. You should have everything you need.
I1 over I2 or I2 over I1?
The fraction of the total is I1, fraction of the total, 5/15ths, not 15/5ths, in my analogy. Here's how to look at that. Wait, who wants more time? Who's having productive discussion? Okay, never mind, carry on. That's a lot of answers. That's a fair number of answers that don't know what decimals are either. Okay, when I say a decimal, do I mean 3/5? 3 divided by 5, is that a decimal? Is 6 divided by 25 a decimal? No, what's a decimal? If it's a decimal, you should include a decimal point. It should be a string of numbers with a decimal point. When I say express as a decimal, don't tell me a fraction. That's a lot of correct answers. I am pleased. But it's not all the correct answers, so let's go for broke. I don't know what I2 is. I don't know what I1 is. But I do know a resistance and the current going through it. What do I knee-jerk reaction know? If I know I and R, I know V. What's voltage across this resistor? The voltage across the 3 ohm resistor is 18. Last I checked, 3 times 6 is 18 anyway. If this voltage is 18 volts, how many volts does the right guy feel? 18 volts is the same voltage. It's the same volts. They're identical. It's the same thing. If the distance from my foot to my head is 6 feet, the difference from Sahyu's foot to his head is 6 feet, then it's the same 6 feet, unless he's standing on my shoulders or something. Okay, so if there are 18 volts across the resistor, now I know something different. Now I know something else. 18 volts, 2 ohms, what do I know? What can you immediately conclude if you know the voltage across the resistor and the resistance of the resistor? Google Form J, what can you immediately conclude if you know the voltage across and the resistance of? Immediately, fast, fast, fast. I tell you V and I tell you R, find what? What can you find? Fast, 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 come on. Yes, good. If you know V and you know R, then you know I. 18 divided by 2 goes by the pseudonym 9. Okay. Amps. So I've got 9 amps going through the right sucker and 6 amps going through the left sucker. How many total amps must there be? 15. 6 people walk out of one door, 9 people walk out of another door. How many people must have walked in the first door? There must be 15 total amps. 6 plus 9 is 15. Total current in equals total current out of any point. That's one of the laws. Can you tell me what fraction 9 is of 15? 0.6. Okay. A lot of you got this. Great. I want it all. I want it all. Please turn to your neighbor and teach them what the heck, how to do this, how to find currents, and how to find ratios. Say that again? Google question J was, if you know voltage and resistance, what can you immediately conclude? What is the knee-jerk reaction? And the correct answer is current. Okay, when you teach each other things, you will inevitably realize that something escaped your notice. Please do not just sit there. Do not wait for physics to occur to you. Don't blah, blah, blah. Ask. Show me where you are confused, and I can reveal all. Sweet, then y'all are getting 100%, right? Not a single question? You all get this perfectly? That's what you're telling me? Hey, by the way, what's 9 amps divided by 6 amps? What's that ratio, 9 to 6? 3 to 2? What's the ratio of resistances? 2 to 3? If this sucker has 2/3 of the voltage resistance, then it will have 3/2 of that sucker's current. That's another way to say the current ratio in parallel circuits. If it's 2-to-1 ratio of resistance, then it'll be a 1-to-2 ratio of current. Okay. Last one. My symbol here is there's some other circuit connected. There's stuff here, but I'm not going to tell you what this is. I don't care about it. I only care about this fraction of the circuit. You can do this. Chop, chop. You can do this. Quick like a bunny. Quick, 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 quick. I've still got 5 minutes in the period, right? I got 10 minutes. Holy crap, maybe I'll teach you 10 more problems. Oh, crap. You guys didn't see that. That's part of the answer. Oh, what were we? This section is on K. Oh my God. The 3 o'clocks required much more help, much more hand-holding. Yeah, Jane. Tote. By the total resistance. Or the French resistance, you know, one or the other. Did I finish my coffee? Oh, good, a correct answer. 2, 3, 4, 5. Let's play the color game. Okay, there are a lot of wrong answers. For, I think, a reason that you weren't paying attention when I said that there's more to the circuit. Okay, these lines lead off to other stuff. I am asking the resistance from the pink to the green point. That's different than if I said this is the entire circuit. If this is the entire circuit, there's nothing else, then this is not a junction. But I'm saying there's stuff down here. Current is leaving this point. This is a junction to a third, fourth, billionth component. The top, the pink, that dot there, there's more circuit. R1 and R4 are not in series. No, it doesn't. Well, I mean, depending on which way you're reading it. If you're reading it in a certain direction, then yes. Does everybody, and I mean everybody, agree that R2 and R3 are in parallel? You see that. Orange, green, same pair. What's 30 plus 45 in parallel? It's not 75. What's the parallel combination? 30 times 45 over 30 plus 45 is 18. Okay, so how is R1 connected to R23? Ask yourself that. R23 is an orange to green resistor. The equivalent resistance of R2 and R3 is a single resistor that goes from orange to green. Is there any other orange? If I have combined 2 and 3 into a single? Question? Because there's more circuit up here. That's what I was saying. There's a junction, there's a branch, there's a split. Current has a choice. Yes, that is correct, Fairtish. Yes, absolutely. That's the answer. Okay, so hopefully you see R1 is in series with R23. These together make 42 plus 18 is 60. And finally, are R1 and R4 connected with unique colors? No, they're not. As I've said 4 times now, there's more circuit that way. There are other pink components. There are other green components. That's what the smiley face has. That's what the rest of the world has. There's more to it than that. So they're not unique pairs. So they're not series. The current in R1 is not the same current as the current in R4. Things are in series if there's no junction, and I see junctions. Unless that junction's a voltmeter. Never mind. I'm not going to give you that. Okay, so if they're not in series, what are they? How is R123 connected to R4? Parallel. Pink, green on the left. Pink, green on the right. Oh? You don't like that? Ask me. Ask me. Ask me. Where'd I lose y'all? There are some happy faces, but there are a lot of sad faces. Here's a happy face. Now let me make your happy face too. Do y'all see that this is parallel? Like really, truly, very see that's parallel. Good. Do you see that this combination is R1 is in series with the combined R2-3? That feels good. When R2 and 3 smush together, there's no longer a third thing sharing the orange. Okay, now, if there is more circuit above the screen, is pink unique? No, that's not series. What's the top of R123? What color? Pink. What's the bottom of R123? Green. What's the top of R4? What's the bottom of R4? Are those the same things? Yes. They're in parallel. Okay, so now I ask you, what's 60 parallel 40? Google. Calculator. Multiply two numbers. You can do it. I've shown you about 60% of the midterm one. You have seen, we have discussed, we've gone over everything that I'll ask on 60-ish% of the questions. We will have additional time to review this. I'm going to add another bit of magnetism, little gentle bit of magnetism next week. And then we'll also have a Monday to review. Questions before I let you go? I love each and every one of you because you are all the best. Adios.